Hey guys, welcome back to another Default Cube CG Matter tutorial, and in this one we're going to be doing a very cool effect that just takes forever to make, but you're going to learn a lot in this tutorial if you watch the whole thing through. So first of all, what is the effect that we're going to be making? You see we just have some footage that I recorded of just this area, and then, oh, this Batmobile kind of appearance happens, like a secret layer thing. And that's the whole effect. It doesn't look too good because I didn't spend too much time on it, but I guess really the cool thing about this is the concept. So how do we do the motion tracking? How do we get a texture on our geometry that actually sticks and rotates with it? And then also how do we add, objects into our scene? So once you learn, the concepts behind this, you can of course replace this with a photorealistic 3D car model. You can make the floor like rock instead of this checkerboard, and yeah. So again, this is going to be a super long tutorial, so I'm just going to relax. You guys should relax, and hopefully by the end of this, you understand the whole process. And what is that process? Well, first of all, we're going to take our footage, which I need to mute the audio for, so I don't forget. We're going to take this footage I recorded, or you could record your own footage. We're going to take this, convert it into an image sequence, so instead of a video, we just have a list of images, and this makes motion tracking a lot easier, because then we don't have to worry about frame rates and all that. So, video, image sequence, we're then going to do our motion tracking, and then we're going to make our 3D scene and put the texture on the box and everything. That's basically the workflow, so let's get started. I'm going to be using Blender 2.82. You can use whatever version of Blender you want. So, with Blender open, what I like to do is hit Control N, which is going to start a new file, but we're going to use the video editing preset, because again, the first thing we need to do is convert into an image sequence. This is the fastest way to get here. Click Add, click Movie, and now we just want to import in our original footage. For me, that's on the desktop, and we'll see if I can remember which one. It's this one. Remove the audio layer. And you see we now have our footage in here, and really, before we export as an image sequence, we want to ask ourselves, do we want to trim this footage? That's really the only thing you need to care about, because all this frame rate stuff should be set automatically when you import your footage. And in the Render tab, you're going to notice under Color Management, we have Standard View Transform, which is something I always talk about, because usually you have Filmic and it makes it look weird, so Standard fixes that. But trim your footage if you want to, so I'm going to have it start on frame 1, and let's say instead of ending, 250, which is past when the footage ends, we can make it like, I don't know, something like 200. Cool, so now we're going to have an image sequence from frame 1 to 200, and to output that, just go to the Output tab, and we're going to do a PNG sequence, although you could get away with JPEG, but you want to minimize compression and you want to minimize artifacts and all that. Because the more data you have, the better it is going to be for motion tracking. So PNG is a good way to do that. We're going to drop the compression and output. We don't need an alpha channel either. We are going to output this on our desktop. And do I have a folder pre-made for this? I don't think so. I can make a folder. So create a new folder. We're going to call this rolling floor. Probably rotating floor would have made more sense. Doesn't matter. Sequence. Except Control F12 to render out the animation. Okay, I feel like maybe this is only going to be a 20 or 30 minute tutorial. We'll see. The motion tracking is actually going to take the longest. We're going to try to do it manually, even though an automatic solution might work. Even though Blender's automatic stuff doesn't really exist, you could just automate putting trackers on the scene. Okay, let's see how long I can talk until this is done. Okay, cool. Now that your thing is rendered, you're going to notice that in whatever folder you made, you're going to have an image sequence. This is good, and it goes from frame 1 all the way to 200. Okay, cool. Next, we're going to ditch this project since it doesn't have a lot of the pre-made workspaces that I want, so Control N, and then we're just going to use a general. No need to save. Okay, so next step is motion tracking since we're done with the image sequence. To do this, go to the movie clip editor and click open to import. We're going to import our rolling floor and just, I think you can either select just the first frame and it might auto detect, or you could just hit A just to make sure that will select everything, and then open clip. Okay, cool. And before we forget, there's a couple things we need to make sure are correct. First of all, in the Render tab, under Color Management, like I talked about before, it's by default Filmic, so set it to Standard, and you can see that actually switches it a little. So Filmic, Standard, this is important that you get right. And then the only other thing is this is now frame rate independent since it's an image sequence, but we do want to match the frame rate at least as close as possible so we get the same speed of playback, even though it doesn't affect motion tracking. So I think this was 30 frames per second. Okay, finally, we are going to save, call this untitled, and we are ready to begin motion tracking. Now I'm going to assume that you know a bit about motion tracking or have seen some of my tutorials, but I can try to explain this as if it, maybe not as if this is your first time, but I'll give you a little hand holding here. So first of all, you're going to notice that none of this is cached, meaning that if we click play, it's pretty slow. So first of all, we're going to hit prefetch. That's going to put all this into memory. Next, you're going to notice that we also have the project going to 250 by default, even though it's 200. So you can either type in 200 here, or if you're lazy, just hit set scene frames, and that does the same thing automatically. So now we have a project going from 1 to 200 with smooth footage or an image sequence playing because it's all in memory. Okay, so now to do our motion tracking, we need to get 8 trackers existing throughout the whole shot. At least any 8 can switch between which 8 those are. So we're going to start off by setting up our tracker. So we want normalized so it can be invariant to lighting intensities, which I don't think is an issue here. We're also going to use either perspective or affine. Perspective is better but takes longer, but it's fine. We're going to use perspective, and this is going to let it track changes in perspective with our tracker. And then finally, in our tracking settings extra, I'm going to have it have a higher correlation, meaning that it needs to be 90% accurate frame by frame, otherwise it's going to stop. Okay, cool. So now you know what all those mean, and we're going to control click, maybe this leaf and make that a bit bigger. Alt S for our search box. This is where the tracker, this pattern, this is where the tracker is going to look for this pattern within this search box. So you want this big, but not too big, because the bigger it is, the longer it takes to calculate. Once you're happy with that, you could track forwards hitting, I think, this button. No, this button. Or you could memorize the shortcut, which is Control T. And you can see that is tracking very nicely. And it made it to frame 150 before losing it for some reason. So let's go back a frame. Maybe the search box needs to be a bit bigger. And then Control T again. Okay, this one made it to 170 now. And the issue is you can see our pattern area has now hit the edge. So we can just correct that by making it smaller. So this is just a lot of manual tracking stuff. Now, it's definitely not going to make it to the end of the footage, so we can just end it here at 176. So lock it by either hitting Control L or in the track, which is all the settings for this tracker, lock it like this. Okay, so now we want to try to pick trackers that exist throughout the whole shot, so maybe a bit further back is the way to do this. So maybe this thing would be a good contender. So same thing as last time, Control T. And then after a bit, we're going to start not doing them one by one so that we save a bit of time. By the way, if you're wondering how I centered this on the screen, you hit L or this button to lock it to the center. That made it all the way through. Control L. So now we have 2 trackers that exist almost throughout the whole shot. We need a few more. And it's a good idea to pick them at different depths and at different 2D locations. So right now we have them focused on this area of the screen. So towards the center, we also want ones on the top, the bottom, the left, the right, and again, also in different depths as well, in 3 dimensions. So this is a good contender for all those things I just talked about. Control T. Hopefully this stays in frame. It looks like it might not make it. You know what? I'm just going to restart this one and have it track kind of like the bottom of this too, because then I think we'll run into less issues. Nope, that is definitely not making it. Either way, we can lock the tracker, pick some other options. Now, I did track this before, but I didn't really remember which trackers I used, so I can just check this or use this piece of the wall here. But I forgot what the best trackers were for this, but that's fine because that means we're going to discover it together. So far, I think we only have 2 trackers that last throughout the whole shot. Let's try to get this one. I think this is going to be a good contender. And really, when I'm looking, whoops, that is not doing too well. We'll let it finish. When I'm looking for trackers, I'm just looking for areas of high contrast and areas that have a bit of detail as well, is how I'm picking these spots. So I think this one should be pretty good. Lock. And really, we only need 8 of these total, so it's not that long of a process. You just need to pick good options. So that one was fast. What else? And again, with your footage, assuming you're not using my footage, by the way, if you want this footage, I'll probably make that available on Patreon if people want it. But if you're using your own footage, it's really just about applying these principles, because you don't really know what trackers to use since I'm demonstrating on my own footage. So really just look for areas of high contrast that have a good amount of detail and have a good variety in 2D and 3D location. So really I'm just hitting Control T a bunch of times until it makes it to the end of the shot. So we have a bunch here. It'd be nice to get some on the right or the left or the foreground. Let's try the left. I'm seeing a good tracker over here, although I have a feeling it's going to go off frame. Oh, by the way, there's some heavy perspective distortion because this curb thing is much higher than the floor. So let me not use that. Instead, we can sample only from the floor, although that should go off frame pretty quickly. But we can lock it anyways. What are some other good options? Of course, this whole ground area, almost all of it is a good option, even though it's a bit repetitive, but I don't think the tracker is going to have any issue with that. And by the tracker, I mean Blender's tracking algorithms. Okay, we can make that a bit smaller, the pattern. Doesn't need that much data. But the reason I'm not just using trackers all from the floor is, again, that's not going to actually give us a solution. It might even give us an error because it's not able to solve because it doesn't have any difference in elevation, which is important usually. But I think we are almost done. It's a shame that all these trackers aren't making it throughout the whole shot. They keep hitting the edge of the frame, but that's fine. Even if you have trackers that exist half the shot, they're still worth having usually. Generally, if it's a good tracker, then it's worth having. If it has a lot of sliding, then, get rid of it. Okay, that was a good one. And I feel like we only need 1 or 2 more that exist throughout the whole shot. Let's try something over here. I'm thinking we sample from here as an obvious choice. Although, seems to have the issue. Whatever, we'll lock it there. And then of course we can also, since we have a lot of trackers that exist halfway through, we want the same thing but in the other direction, so you can go to the last frame, that's shift right arrow. And then we can just pick one and then track backwards. There's no reason we can't do that. So let's do something like that, although I have found that tracking backwards is a bit slower for some reason. Instead of Control T, you either hit this button or Shift Control T. Yeah, you can tell that's a bit slower, and it's not just because I picked a large pattern in a search area. It definitely is slower. But this way, I think we can guarantee that this one will last throughout the whole shot. And soon, I think we'll be done in terms of having 8 trackers existing throughout the whole shot. Okay, cool. You know what? I'm not sure if we have them, but I think we might. So let's assume that we do. If not, we can always add another. Once you've added your trackers and they're all locked, again, hit A and hit Control L just to check. Then we want to go to the Solve panel. And we don't want to enable tripod since this isn't a tripod shot, it's moving. It's a free move through 3D space. You could pick a keyframe A, keyframe B. I'm not going to explain what those mean because I've done that whole explanation before in a 4-hour tutorial. But what you need to know is that we don't want to pick these numbers ourselves because I don't want to do it. So instead we're going to enable this, which is going to pick 2 values that should be pretty good. Okay, and then solve camera motion. And it seems to be processing, so maybe we do have 8 trackers. And right off the bat we get a solve error of 0.9. And that kind of describes the drift in pixels that you can expect per frame. So under 1 is pretty good. Ideally, we want this as small as possible. So what we can do is, if we're okay with this, if not, you can just keep hitting this button, although we might just get the same solution. Once you're okay with this, what we're going to do is we're going to disable keyframe. So now we've locked into these 2 that it's selected. We don't want to have it keep switching. And then we're going to refine. I don't want to do distortion for this tutorial, even though it might be a bit important. We're just going to do focal length. So again, it's going to use these keyframes, but now we're also going to ask Blender to guess what focal length my camera was. How zoomed in was I? Solve. And notice that once it compensates for this, our error has dropped with the same keyframes, has dropped from 0.9 to under 0.5. And yeah, we could probably do a bit better. Like we could change the weights of some of these trackers and everything, which might be something we can do. Let's look into it. I want it to be a comprehensive tutorial. Let's enable info, and that's going to show each tracker. It's going to show the average error. And notice this 0.48 is the average of these averages. So some of these have to be pretty high, some of them pretty low. So I'm seeing some like 0.6s, some other stuff. Now this isn't like a 100% technique, but generally if you pick a high error tracker and just bring down the weight a little, we can have it solve again. And now we've gone from 0.48 to 0.46, and then all these errors update. I'm just going to tackle this one since it has a pretty high error. And generally, you can use this method to whittle down the solve error closer and closer to 0, but you don't want to overdo it because at that point, you're not going to get a solve that's representative of your shot anymore, most likely. Again, all these things depend on a shot-per-shot basis. Okay, I'm happy with 0.42. I would have been happy with 0.9 as well. Okay, this is fine. Now, what do we need to do? We need to take our solve and put it in our 3D scene. So, set everything up. How do we do that? Well, first of all, I'm going to show our viewport just so we can see that stuff is imported. I'm just going to delete everything. So once we have our camera solved with a good solve error, we're now going to hit Setup Tracking Scene, which is going to take this or takes our camera solve and puts it here. And notice that our camera, when we click play, is now moving. And how is it moving? Well, it's moving, hopefully, in the same way that our real physical camera is moving. Now, you notice that it might be doing the trick. However, this floor, this plane and cube kind of looks like it's drifting in the air and not attaching. And that could be because we have a bad camera solve, but really it's because our coordinate system is all off. What do I mean by that? Well, these trackers, at least the ones on the floor, so these ones, not the ones up on the wall, these trackers should be on the XY plane. And if we haven't oriented our scene correctly, that won't be the case. So I can just select 3 of these, so just any 3 that are on the floor, and then hit the floor button, which you can see just repositions our camera such that now it kind of looks like everything is accurate, although it's way too big. So what we can do is we can first center it, pick a tracker, and make this our origin. So this is where the world origin is going to be. And then let's choose, relative to this origin, something to the left or kind of like down the y-axis. So I'm going to pick something down the y-axis. So imagine that these 2 trackers are forming a line, and I want that line to be our y-axis. So you see that reorients everything. And then finally, for these 2 trackers, I'm going to set scale to something like 4. So there's going to be 4 blender units or 4 meters or whatever between these trackers in 3D space, which I think already looks pretty good. So now let's see what we have. It's not going to be perfect since, we didn't spend too much time on it, but you can see it's definitely somewhat correct. Okay, let's do a save. So now, let's do a bit more correction before we're done. So this origin, I feel like, is too far back. We want it kind of like here, closer to where I would be filming. And you could do that by like moving this plane towards the camera, but I want all this stuff to stay on the origin, so really we just want to move the camera, which will make it look like the other objects are moving. So select your camera, and then G, Y, and then we're going to pull that just a little. And then we can also do some rotation on the Z-axis to make this kind of, we want this line of the plane to be parallel to this curb. And I think we did that. And now GX, although we could fix this a bit. You see it's not perfectly parallel, so RZ. And you know what? We can't make it perfect, but this is much better than it was before. And you can check that it's working okay by just playing and seeing if it looks like it's on the floor. Okay, I think we are done with motion tracking. Cool, we did the image sequence, we did the motion tracking. Now it is setting up our scene and putting this texture on the geometry. So first of all, let's get rid of this cube and take this plane and scale it down. And really what I'm doing is I'm defining what area do I want to be our like not a turntable, but what do we want to have the ground flip, or where do we want it? Either way, just scale down your plane. Now because we want this to be 3-dimensional, most likely. You don't need it to be 3-dimensional, actually. Maybe we should do a 2D version for this one. Let's do it. So normally what I did before is I just, went into edit mode, E for extrude Z, and that just gave a depth, so it's more like a block rotating, but really the principles are the same. And in fact, the method I'm about to do, which I haven't done before, will actually teach you a bit more. So we'll do an infinitely thin thing. So first thing we need to make sure of is that this has a UV map, which it should, but let's check UV editing. Yes, it's a single face, which, or does it not have, I guess it doesn't. Let's see. Either way, select your face, U, unwrap, now it's unwrapped. I guess when you hit setup tracking scene, the plane that it adds by default doesn't have a UV map, but now it does. So again, I just hit U, unwrap, now it has a very, very basic unwrap. So now the question is, how do I get my ground texture, at least the section of the floor, that it's kind of overlapping here, so how do I extract this texture and put it on here? There's a couple ways to do that. Ian Hubert would say project from view, which I don't think is probably the right way to do this. It works. Here's what I would recommend. What we're going to do is we're going to find a frame where it's all in frame, so this wouldn't be a good one because the corner's cut off. And maybe I'm just going to move this a bit further, deeper. What we want to do is pick a frame where it's all in there, but also we want to pick a frame where we're the closest to it. Because imagine we're extracting this texture. We want this to be the highest resolution possible. If it's off in the distance, we can only extract like a 25 by 25 pixel thing. Here we can extract maybe like a quarter of the frame. It's taking up about a quarter of the area of this 1920 by 1080 frame. So get as close as possible. I'm going to say that this frame is fine. And then we're going to go to the shading workspace and create a material for this. Although I did run into this issue before, the same way this didn't have a UV map, and it might just be because of like this whole foreground background issue. I guess so. Basically what I'm doing is this setup tracking scene sets up a lot of stuff that I don't like, and one of those things is all these collections. We can actually just get rid of that. So I've just moved everything into the foreground collection, and also in the compositing workspace it adds all these nodes, which in this case is helpful for us, but whatever. Either way, we have our plane. The material is now showing up because I moved everything into the foreground, which means we can also delete this background view layer. Don't worry about that. Okay, cool. And notice that, this material is updating. So how do we get the texture to extract and be projected onto there? Well, the way we do it is we're going to add a image texture. We are then going to select whatever frame we're on. And in this case, I think we're on 126, but let me just make sure. Yeah, we're on frame 126. So what we want to do is import not the image sequence, but just the frame that we're on. So in this case, 126. So open, rolling floor, and then find 126, which might be different for you, depending on what section of the floor you want. So 126. And you see that this is definitely the same image that we're seeing. However, it's not that section of the floor. It's just kind of putting the whole thing there. My ears are hurting. That's why I keep, whatever. How do we fix this? You're going to hit Control T if you have Node Wrangler. So that's Edit, Preferences, Add-ons, type in Node Wrangler. And you can just enable that. If you don't want to do that, just add a mapping node and a texture coordinates node, I guess. Actually, we don't even need the mapping node. You just need texture coordinates. So if you don't want to do Control T, just Shift A, texture coordinates, and instead of using UV coordinates, we're going to use windowed coordinates, which you see does the right thing. And you're going to notice that this is kind of like brighter, or at least higher contrast than the background. And that's because it's not an issue. It's because if we go to camera settings, background images, we just need to crank this up, and then it will be the same contrast or whatever, brightness. Either way, windowed coordinates work, although if we go in 3D view, you see it's just going to take whatever section of the screen we're on, so it's view dependent in some sense, so we want to make sure we're looking from the camera for this to be correct. And then you're thinking, okay, that's fine, but how do we rotate this? If we rotate this, it's not sticking with the texture. It's actually just updating as we do it. What that means is we need to bake this texture, and then it will be applied to this, and we're going to use UV coordinates then. So I'm going to duplicate this image texture node and just get rid of the, frame 126. Instead, we want to create a new image, and the nice thing about this is since it's a plane and the UV map or the single UV island, UV face takes up the whole thing, all our resolution is going to be used in a good way. So we can click new, and we don't even need anything that big. So this is fine. 1024 by 1024 is fine. And then now we're going to do our baking. If you don't know how to bake, you need to make sure you're in cycles. Eevee doesn't bake. I don't know if it's like a feature that's missing or it's impossible because of what Eevee is. Either way, go to cycles. We'll use GPU. You only need one sample for this. And then make sure that your object is selected, in this case the plane. Make sure that the node where you created the new image is selected, so in this case this one. And then go to bake, and we're just going to hit bake. Cool. And you see from here, this is all baked in. It's kind of like we extracted that piece of the image and just made it a square, which is nice. And you can think of this image, which we can save, by the way, that's Alt-Shift-S, I think. We could just save it on here because when Blender closes, it doesn't necessarily save it. We'll do this, so save, although this isn't necessary if you don't close your project. This texture is stored in here, this node, which means we can delete this, connect it here, and notice that now it looks the same as the windowed coordinates thing, but now if we go to 3D, it kind of sticks on there, right? It's not view dependent, and that's because it's using either UV or generated. In this case, I don't think it matters. Maybe it flips it? I guess it flips it, but generally it doesn't matter. Okay, cool, which means we can now rotate it, and you can see it's sticking on there. Now, of course, we have the issue of both sides of it. Both sides of it are bricks, whereas before, what I showed you is this kind of like thick thing I made before. It wasn't a plane, but it was a cube, and I was able to get, different materials on different parts of it. So the question is, how do we apply material to this side and then a different one to this side, even though they're the same face? Which hopefully I can figure out on the spot, since that's what I said I'd be doing differently in this tutorial, but don't worry, there's an easy way to use this to our advantage. So let's say that we want this as our top face, and for our bottom face, it doesn't really matter. I'm going to use a checkerboard, although you could use like a different image texture, it doesn't matter, or you could use a color. So how do we get this on one side, this on the other? Well, the trick is you add a geometry node. And notice that we have something called back facing. I'm going to view it. Back facing, you're going to notice it's just black. However, if we look at the bottom, hopefully, it's white. Meaning that we've somehow isolated the top and bottom of the same face, which is strange, because what you need to realize is this isn't like a face and then a different one down here. It's literally changing the color just as we go above the horizon, but you can't tell. So that's the nice thing about back facing, which means you're thinking, okay, fine, how do we use this? Well, what we do is we mix these together with a mix RGB. You can either add a mix RGB or use the shortcut, which is Control Shift right click drag. So we're mixing these together, which kind of makes them each 50% transparent. But if we use this as our factor, this back facing, you're going to notice brick, checkerboard, even though it's one object infinitely thin. That's the way we do it. And additionally, there's no reason that we can't, instead of doing a mix RGB, we could take it one step further. We could do a mix shader. We'll view that. And then we're going to plug this in here, back facing as our thing. And you're thinking, okay, what's the difference? Well, the difference is we can now use BSDFs, which means I can add in a diffuse BSDF to the checkerboard version. Sorry for the cut there, had to figure something out quickly. I don't know what I was talking about before, but either way, make sure we switch back to Eevee and then go to rendered mode. I think I was running into a rendered mode issue. What I was saying is that we're going to put a diffuse BSDF in this checker texture, which means that if we move around our light, which I think is what I was talking about, this reacts to our lighting. However, the bricks do not, which you think, oh, why wouldn't we want that? We could just put another diffuse there and now it's reacting to the lighting, right? Why do we not want that? The reason is if we have it react to the lighting, it's not going to blend in with our shot. Again, let me show you. Diffuse BSDF, now it's not blending in. Even though it has all this nice lighting, it's not what we want in this case. And what we could do is we could have it turn more and more into diffuse BSDF as this object rotates, which is fine. You could do that. I'm not going to do that. So either way, we upgraded to a mix shader, which means that on our top, which is one side of our back facing, on our top, we're just going to have the image just pumped raw into the material, no processing, nothing. And then on the bottom, we're going to use our checker, but it does react to lighting. Okay, so that is our material. We could do some other fancy stuff, but that's fine. And the nice thing about this is it's one material instead of two materials with the thicker cube solution, but that's fine. Next, what we want to do is, even if we animate this rotating, you still see the ground below it, right? Because the footage is in the background. There's no like hole beneath. To add that, what we're going to do is we're going to duplicate, Shift D, right click to center, and then we're going to call this hole or something. For this one, we're going to create a new material. We can just have it be a BSDF, that's fine. And I like the idea of making it a bit darker, something like this. And we want this to be our hole, so we're going to go to Edit Mode, Extrude, that's E, Z, downwards. And then we can also delete this face. So it's kind of like a bowl, if that makes sense. If we hide this, it's kind of like a bowl. And we can make this a bit lower, like that, such that when we play this, it doesn't really show up anywhere except on this edge here, which we're going to fix. But when we rotate this on the y-axis, you see there's now a nice hole there. And we want to add a bit of lighting so we can actually see what's going on. So like 500, make that a bit higher, make that a bit softer. So now when we rotate, yes, now we can kind of see what's going on. And again, you can make better lighting than I am. I'm just not going to do good lighting, which is whatever. That's just my thing. Okay, so now the question is, how do we fix this side that we see? So for example, if we hit render now, actually, first of all, render tab to get rid of the background, render tab, film, transparent, F12 to render. You're going to notice that it kind of looks like nothing has changed, even though our plane has actually been rendered. It's just overlaid and has the same perspective, so it looks the same even though the texture's on there. But you're going to notice that we do have this issue over here. So we're going to need to fix that. So the way we fix that is, notice that we could correct it for all 4 of these sides, but I think it only shows up for this one. So what we're going to do is we're going to, actually it shows up for these 2. So we're going to go into edit mode. We're going to select this. We're going to extrude it, so it's kind of obstructing our view of this, and same thing for this one. In fact, we could extrude both of these this way. So think of these 3 faces as something that's blocking our view. So imagine these 3 weren't here. Does that fix the issue? Yes, now we can't see it. So now, what material do we want to give to these 3 to fix the issue? Well, first of all, we're going to go to the Material tab. We're going to create a second slot with a new material. So now we have one object with 2 material slots. And for the second material, we're going to call this holdout. And all we need to do is we're going to add in a holdout into the surface. But you see it's not updating, and the question is, why is it not updating? And the reason is, while we do have 2 slots, all the faces belong to this first slot, meaning that we need to have this material selected, go into edit mode, we're going to select these 3 faces, holdout, assign. So now we've assigned our holdout material, or really we assigned the second slot to these 3 faces, which makes it transparent, which kind of looks weird in the viewport, but when we hit render now, it should look like, nothing has changed. Even though, again, if we go to compositing, and luckily all these nodes are already here for us, but if we go to compositing, you see this is what we rendered. Just this plane, and everything else is transparent, and then we just overlaid it on top of our footage. And by the way, since I got rid of the background, we can get rid of this node and get rid of this node. But you don't need to do that. It's fine if you keep it, I think. Okay, cool. So now we have our basic setup. So now the rest of it's pretty simple. So what are we going to do? We are going to go like 60 frames. Then we're going to select our ground. I for keyframe, rotation, and let's have it take like up to frame 110. Doesn't really matter. Rotate on the y-axis by 180, minus 180. And notice that now we have our checkerboard and it's reacting to lighting slightly. So here's what that looks like. And because of our setup, it's going to look like there's a hole in the ground and we can't see these exposed faces because of the holdout shader. So that's the beauty of the setup. So let's render like an intermediary frame. Yeah, you can see it's really reacting to the lighting since this light is right above there. So now really the final component is just having some object be there. I had a monkey. Doesn't really matter what you pick. So Shift A, Mesh. Let's do a donut for this one. And I'm just going to position it so it's right above the floor. And then how do we make it inherit the rotation motion? Well, obviously, select the object, Shift select the other one. So now both are selected, but this is the active one. Control P for parent, and then by object. So we made this torus the child of this parent, the rotating thing, which means they're moving together. But since this is infinitely thin, it's kind of poking out the bottom there. So what I'm going to do is I'm just going to make that tiny bit lower, like that, which should still look good. So this is what it looks like on the last frame. Notice that our lighting is still here, and you're going to want to match the lighting. You know, this kind of looks like it doesn't fit in here at all, and it doesn't, but you could spend time doing that. I've spent time making this tutorial. We all need to invest a bit of time into this. Okay, so let's say that is our final shot. And again, we don't need to worry about compositing nodes since it does it for us, but if you're curious, what's happening here is we have our movie clip, which is basically our footage. It's just what I filmed. You're not going to see any rendered layers on top of it. So it takes this, it throws it through a undistortion, which in this case doesn't matter because we didn't try to calculate our K1, K2 lens distortion value. So this node effectively does nothing, so we can delete it. So we have our footage. Whoops. We have our footage. It's then scaling to fit, which in this case, again, doesn't matter. If we picked a different output resolution than 1920 by 1080, then it'd matter. So again, we can, I guess, we could just delete it. Doesn't matter. So we have our footage, and then we're using an alpha over node. Keep clicking the wrong. We have our footage, and we're using this alpha over to overlay this, which is our 3D asset, on top of it. It's really that simple. So let's have this be very, very nice and organized. So here's our node network. It's really simple. Let's render a frame. Okay, so now let's say we're happy with our project. Of course, there's more stuff you can add. You can add motion blur. You can add more integration so it doesn't look horrible. But when you're happy with this, we're going to render this out as a video. So let's do FFmpeg, which is a video codec. We're going to choose MP4, high quality, and then we want to export our video as finally done. Control F12 to render. Now, since this is Eevee, I think we switched to Eevee. That's where I cut the video before. Since this is Eevee, it's going to render pretty fast. Now, there is an argument to be made that these frames I'm rendering right now before the rotation even happens is a waste of time. And beyond that, it's actually bad for our final render. And the reason for that is, in the beginning, you're not even going to see anything different from the original footage. It hasn't flipped yet. But additionally, since we projected our texture on, you know, frame 126 or whatever, for all the frames before that, from 1 to 126, you might see a bit of drifting there because I'm assuming that the motion tracking was perfect up until that point. Otherwise, that point will be slightly off on frame 1, which will make it kind of visible where it is. So it's a good idea to only start rendering on frame whenever the rotation starts. So you have the normal footage, and then you cut to the render, which you shouldn't be able to tell that there was a cut. Okay, so hopefully this is almost done. We don't have to have it go all the way to 200 because from here on out, it's just, you know, right there. We'll have it go to like 150 or something. But while that happens, and we are going to watch it, if you enjoyed this tutorial, which isn't over, but if you enjoyed it, Patreon is the best way to support this channel. So anybody who is willing to donate there, I really appreciate it. It really is a major part of what lets me do these tutorials as a job. Without Patreon, I couldn't do it. So anybody who wants to do that, a big thank you for me. You do get benefits like Discord, private private parts of the Discord server you get access to. You get access to some private tutorials. You also get tutorial files, etc. But I see it more as a donation than a purchase. But you do get stuff, so it is kind of a purchase too. Anybody who is willing to do that, greatly appreciated. I guess we are waiting to 200 since I got carried away with the Patreon thing there. Oh, I just scratched my nose too hard. Started crying. Hopefully I'm not bleeding. Either way, here is our render. And then, look at that. So we kind of made a cooler version. It kind of looks better than the original. It has that infinitely thin thing going on. And you're probably not going to see what I was talking about before where there's a bit of drifting, but I can see it. It is there. So really, again, you don't want to render the whole thing, only when it starts turning. And then here is the original, so you can compare. This kind of looks lame in comparison, but it makes more physical sense that it has thickness. So before my nose bleeds out, I guess I should end this again. Anybody who's willing to become a patron, greatly appreciated. But either way, I hope you enjoyed this free tutorial. I've been Default Cube CG Matter. You've been you. See ya.